In this lecture video, we are going to take a look at how to determine the chemical formula. Please read the OER textbook chapter 5.3 for more details, and the homework that associated with this lecture is the Newton homework 5.3. And here are the three types of chemical formula that we will take a look at in this video. The first one is the empirical formula, which shows the smallest ratio for the atoms of each type in a molecule. This empirical formula is used for molecular compound. Similarly, formula unit is also describe the smallest ratio for number of atoms of each type in ionic compound. Because formula units show only the smallest ratio between metal and non-metal for ionic compound, therefore we can also call this formula unit as empirical formula as well, because it shows actually the smallest ratio for each of those type of atom. The molecular formula is showing the actual number of atoms in a molecule. So this is mainly used to describe the chemical formula of molecular compound. Okay, so it's actually show the actual ratio. So what we are going to take a look at is I'm going to show you the difference between each of these three. Okay, so let's take a look at formula unit first, which is going to describe the smallest ratio of each atom type in ionic compound. So we already discussed the formation of the ionic compound. For example, when neutral magnesium atom react with neutral oxygen, magnesium is going to transfer its electrons to oxygen atom, right? So oxygen atom would accept it. Therefore, these two are going to become cation and anion, and those cation and anion are going to attract to each other, and eventually they are going to form the lattice crystal structure like this, right, in all direction. So it's going to be the alternate between the cation and anion in each of these layers. So if we talk about ionic compound, it's really difficult to define where is the border of the crystal. Therefore, in this case, the easiest or the simplest one to represent this is going to be the smallest ratio, because we don't know how many ions exactly within the crystallized structure. Okay, so that's why we are going to have to represent them as just the smallest unit, which is going to be 1-to-1 ratio between magnesium and oxygen in this case. Okay. Again, the reason why we don't do the subscript for this, because if you're looking at this, right, so magnesium subscript to oxygen subscript to, this is not the smallest ratio. So you need to describe formula unit for ionic compound as the smallest ratio as always, okay, because we are not able to define where is the border of the crystal structure, right? So we can't have the subscript to describe them. We know only the smallest ratio between the metal and non-metal. Okay. So for molecular compound, however, we know exactly for each molecule there are how many atoms for each of those molecules, right? So for example, when we talk about butane, right, we know that the chemical formula for butane have to have 4 carbon for every 10 hydrogen, right? For glucose, it have to have 6 carbon for every 12 hydrogen for every 6 hydrogen. For nitrous oxide, you need to have 2 nitrogen for every 1 oxygen, for example. So this is an actual chemical formula for molecular compound. We know exactly that the molecule will end with this ratio of atoms. Okay, so why do we care about the empirical formula then? So pretty much scientists determine the molecular formula from the empirical formula. The empirical formula is the smallest ratio of molecular compound. Okay, so for example, if the molecular compound is for C4H10, then the empirical formula, the smallest ratio of that would be 2 to 5, right? Because you are going to divide this until you get the smallest ratio of between carbon and hydrogen. Same thing for glucose as well. The chemical, because the molecular formula is C6H12O6, therefore the smallest ratio, which represent by the empirical formula, would be CH2O. Okay, so nitrous oxide, this is already in the smallest ratio, so therefore in this case the empirical formula and the molecular formula can be the same as well. Again, the importance of the empirical formula is to the scientists would determine this first, and then after they know the simplest ratio, then they can actually deduce to get the actual ratio if they know the overall mass of the molecule. Okay, so we are going to learn about this calculation technique in a few slides here. Okay, so pretty much in calculation or in real life, we are not caring about the empirical formula much at all, but the empirical formula is actually help scientists to determine the actual chemical formula of each compound. Let's us take a look at how to determine the empirical formula. So this example can be found in the lecture manual, page 78. So pretty much what you see earlier from the previous slide, we know that empirical formula show us the smallest ratio of each atom, right, in the chemical formula. So this smallest ratio is actually expressed in the smallest ratio of mole to mole. Okay, so it's the mole to mole ratio. Therefore, in this case, in order to figure out the mole to mole ratio, you will need to convert the grams to mole first. So for example, in example number 1 here, it's asking to determine the empirical formula of the compound that contain these many grams of nickel and these many grams of iodine. So pretty much if you think about this, because we are going to look at them as mole to mole ratio, and of course mole and grams are associated by the molar mass, right? So therefore in this case, what you will need to do is that you are going to set up the grams of each, because we want to know these many grams per these many grams, so how much are they in the ratio, and we are going to compare them. So the first step would be convert each of these into their mole. In order to convert from grams to mole, you already learned from the previous chapter, you need to use their molar mass, which is grams per mole, right? So for nickel, in every 1 mole is contained this many grams. This value can be obtained from the periodic table. Okay, so you are going to get this many mole for nickel for these grams of nickel. Okay, do the same thing for iodine as well. So 1 mole of iodine contain this many grams of iodine. If you convert this to mole, you are going to get this many mole of iodine. Okay, so up until here, these 2 mole are not the ratio yet. It just tells you mole of nickel and mole of iodine. It doesn't tell you the ratio between these two. In order to make them to be ratio, or how many of them per the other atom, you are going to divide. The second step would be divide the mole by the smallest mole. Okay, to get the mole to mole ratio, you are going to divide these 2 numbers by the smallest number of mole. And between mole of nickel and mole of iodine, we see it clearly. Mole of nickel is less, right, than mole of iodine. So I'm going to have to divide both of these mole with the number of the least amount of mole, which is mole of the nickel. So that way we know that per nickel, right, so it's going to be equal to 1, right? So because these 2 divided by each other is going to equal to 1, and then of iodine would be 1.999. So that means in this case, if you're looking at it, the ratio between mole to mole between iodine and nickel would be every 1 nickel, it would require almost about 2 mole of iodine, right? So that's what we know here. So this is what we know as the empirical formula, right? Because we know that this formula right here, per this many grams that they react, is come out to be 1 to 2 mole ratio between nickel and iodine. Okay, so that's how the scientists can calculate for the empirical formula from knowing the mass of each of those atoms within the compound, and get the mole to mole ratio in order to figure out the smallest ratio between the 2 atoms of this compound here. Note that because these 2 are coming from the metal and non-metal, so this empirical formula also can be called as the formula unit as well, because this is the smallest unit, right, of the ionic compound. Okay, because this is of ionic compound. You can do this the same thing for molecular compound as well that contain carbon, hydrogen, and oxygen. Right? So in this case, the way that we are going to calculate for empirical formula would be similar to the previous step that we did earlier. Right? So first, you're going to convert to mole. Second, you are going to divide by the smallest number of mole, right, to get the ratio. So same thing here. However, in this case, it's giving you percent. Okay. So you can treat percent as the grams, because in the previous lecture video 5.2, you already learned how to find out the mass percent, right? So this percent is implied the percent by mass that you did in lecture 5.2, right? So in a chemical formula, how many percent of a certain atom can be calculated by the mass of that atoms, the mass of that element, right? Divide by the total mass multiplied by 100. So this is where the percent coming from. Okay, so the previous lecture, the video that you see earlier, the application of that can be used further to determine the empirical formula. So pretty much these percent are the percent by mass. So that means in this case, it's telling us that percent mean out of 100 is tell us that out of 100 grams of the sample or of the compound, right, you are going to have only 63.15 grams of carbon. So that's what it tells us, right? So if you have 100 grams of compound, okay, so this is how many grams of carbon it would contain. That's what percent tell us. Same thing with all of this as well. So the percent tell us that out of 100, how many each of those elements would present. Okay, so similar to what we did in the previous lecture video again, the previous lecture video, you actually calculate for percent from knowing the mass, but this time we are using the percent to help us to get the mass and in order to convert that into mole. So that means according to this definition, so what I know for sure is that all of these have to come out, like if you add all of this together, it's going to come out equal to 100, right? Because out of 100 grams of the compound. So this percent is per 100 grams of compound. So that means if we assume that the compound is 100 grams, so these are the amount of carbon, hydrogen, and oxygen for the compound. Okay, so the next thing that we need to do is convert grams to mole by using the molar mass, right? So you are going to get the mole of carbon. Do the same thing for hydrogen, you're going to get the mole of hydrogen, and do the same thing for oxygen, you're going to get the mole of oxygen. So similar to the previous one, you get mole first. The next thing is to get the ratio. In order to get the ratio, you will need to divide by the smallest number of mole. And in this case, the smallest number of mole is from the oxygen. So I'm going to divide by 1.97199.825. That is from oxygen for all of these, right? So that way they are going to be the ratio per oxygen, right? So it's going to come out to be 1, and it's going to come out equal to 2.67 and 2.667. Note that when you are dealing with the empirical formula, you cannot round any number if it's not close to a certain. So what do I mean by that is that, for example, if you have 0, right? So this one you are going to round down, right, to the smallest number, to the closest whole number. And if you have 9, you're gonna round up, right, to the next closest to the whole number. Anything between that, you need to find another whole number to multiply in order to get the actual whole number. So in this case, if you think about this, so 2.66, you cannot round this yet because it's not 0 or 9. What you can do is you can actually start multiply this, right, in order to get a whole number. So I can start multiply this by 2, right? If I multiply this by 2, you are going to get 5.33. You can also you cannot round this up. Again, you can round up or down only with the 0.9, right? So you can round that. So that means multiply this by 2 doesn't work. So I'm going to try multiply this by 3. If I multiply this by 3, I'm going to get 8, which is going to be the closest whole number, right? So if you multiply 2.667 by 3, you're gonna get 8.001. So that round up to, like, that's just gonna round to 8, right? Because it's closest to 8. If you do the same thing if you multiply this by 3 and it's work for this number, you are going to have to multiply the rest of this by 3 also. So if you do that, you are going to get the ratio of 3 to 8, right? For oxygen, hydrogen, and carbon. Okay, so that means the empirical formula of this would be CHO, it would be C subscript 8, right? Because it requires 8 carbon per the empirical formula, 8 hydrogen per 1 empirical formula, and 3 oxygen per 3 oxygen per empirical formula. So in this case, note that again, if you see any, like, let's say like 0.1 to 0.8, you are going to need to multiply by something. Okay, so in order to get to the whole number, the closest to the whole number. Okay, so the next thing we're going to take a look at is we are going to use the chemical formula that we determine to help us find out the actual ratio of the molecule, which is the molecular formula. Okay, so the molecular formula ratio will need to be multiplied by a certain whole number value that come from the ratio between the mass of the molecular formula per mass of empirical formula. Okay, so what do I mean by that? Okay, so pretty much if you think about this, okay, so the empirical formula tell us the simplest ratio, right? So that means in this case, we are going to go from the simplest ratio to the actual ratio. Okay, so the actual number of atoms. So if you know so for example, right, if you know the chemical formula of hydrogen peroxide, right, you can actually find out the empirical formula by divide these two by 2, right, to get the smallest ratio. And what we are going to do is the reverse process of this, because if you know empirical formula and if you know what is the whole number that you need to multiply, you can do that the same thing as well, and it's going to give you the molecular formula. Okay, so that means in this case, you can do both way. Okay, so if you know molecular formula, you can divide by a certain whole number to get into the empirical formula. Vice versa, if you know empirical formula, and you know the multiplier, you can also multiply that with the empirical formula to get the molecular formula as well. So the thing is, this multiplier right here that you need to determine is going to come from the mass of the actual molecule, right, divided by the mass of the empirical formula. Okay, so let's take a look at this. What do I mean by that? Okay, so let's take a look at determination of the empirical formula that contain carbon, hydrogen, and nitrogen. Okay, so I'm going to go ahead, set up the same thing that we did earlier, right? So pretty much you are going to convert each of these grams into mole. Okay, second step is to convert mole into mole ratio by divided by the smallest number. So this is the smallest number. So we're going to divide off this by the smallest number. You are going to get 2.999, 2.00, and 1. So this 2.999 is already close to 3. So you can actually round that up. Okay, so that means in this case it's going to be about 3. So the empirical formula of this would be C3H2N. Okay, this is the simplest ratio for this molecule. Okay, it's not the actual ratio yet. What we're going to do next is we are going to determine the molecular formula from that. Okay, so we know from the previous step that the empirical formula that we determine is C3H2N. If you add this mass together, okay, so what we're going to do is we are going to get the mass of formula, empirical formula, which is this mass, right? And you are going to find out the molecular mass as well, so which is this molecular mass, right? So this molecular mass is the mass of the whole molecule, because it said that it's the molecular formula contain this mass. So this mass would be the molecular formula, molar mass, okay? So that means you will also need to find out the mass of empirical formula by adding all of this together. Okay, so there are 3 carbon. Each carbon is about 12, right? So you add them together. 2 hydrogen. Each hydrogen is like about 1, right? So nitrogen is 14. If you add all of those together, this is the mass of empirical formula per mole. Okay. What you're going to do is that you probably notice that the mass of empirical formula is not the same as the actual mass of the molecule. Right? Of course, it's not going to be the same because this is the simplest ratio. This is going to be the actual ratio. So therefore, if you want to know the multiplier for this, what you need to do is you are going to divide the molar mass by the molar mass of the formula, the molecular formula by the empirical formula mass. Okay. So if you do this, you are going to get 6. What does it mean? Well, it means that the molecular formula would be 6 times, right, of the empirical formula. So therefore, the molecular formula would be, you are going to need to multiply 6 throughout this empirical formula. So you are going to multiply 6 to each of these number, right? So therefore, the ratio would be C18, H12, and 6, okay? To check your answer, what you can do is that you can add all of this mass for each of these atoms together, and it should come out to equal to 312 grams per mole. Okay, so that's how you check your answer. If this is the correct answer, when you add all of this together, it should come out equal to this 312.36 grams per mole. Okay, so again, to conclude this, you will need to find out empirical formula first, and the mass of molecular formula will be given. You are going to need to find the multiplier and then multiply that into the empirical formula in order to obtain the molecular formula. Okay, so pretty much for this lecture, this is what we see so far. Okay, so we see different type of chemical formula, right? The simplest ratio described by the empirical formula, one is used for ionic compound, the other used for molecular compound, and the molecular formula is used for molecular compound to describe the actual ratio of the atom within the compound. Okay, so and the step to determine the empirical formula would be you get the mole first, right, and then find out mole ratio by divided by the smallest mole, and then you are going to get the whole number, right? So obtain the whole number to get the ratio for each atom. And then if you know the empirical formula, you can also figure out the molecular formula as well if you know the molecular formula, molar mass. Okay, so you're going to be able to find out the multiplier n in order to multiply back into chemical formula to get the actual ratio of the chemical formula. Okay, so after this lecture, you should be able to start working on your Newton homework chapter 5.3 now.